Right, hello everybody. My name is Mac. I am assigned for Organic Chemistry 8B, and today we're going to be talking about how we can take information that is presented in the form of HNMR and a formula. So here we have the HNMR data, here we have the formula, and we're going to be converting those into a chemical structure. So first, let's see the formula that we have, which is right here. It says the formula is C12H18, which tells me that I have 18 hydrogens in my molecule. So now I'm going to compare that to the HNMR, and as we know, in the HNMR, every single hydrogen must be presented. I see that I have 2 here, I have 1 here, and I have 6 here. So the total is going to be 9 hydrogens. Whenever you see something like this, where the formula tells you that you have 18 hydrogens, but the HNMR data tells you that you only have half of that, all you have to do is multiply all of these by 2. All this is telling you is that the HNMR data is, you have to multiply the HNMR data by 2 in order to get the actual amount of hydrogens that you have, which is 18. So this peak right here tells you that it's 2 hydrogens. This is actually supposed to be 4 hydrogens. But those 4 hydrogens are, you're going to have they're going to be split into 2 groups. One group on one side of the molecule, the other group on the other side of the molecule. So they're symmetrical, and that's why sometimes they just give you half of the data. That will be just sometimes. Most of the times that's not going to be the case. But I just wanted to do one example like this, just in case if you see it on a test or on a quiz, so you will be able to answer the questions. So always look at the one that is in the chemical formula. The one that's in the chemical formula is always a true one. And whatever is in the HNMR, you could just multiply that by 2 or 3 in order to get it to the correct one that matches the chemical formula. In this case, it's by 2, because we have 9 in the HNMR and 18 in the formula. So that's good so far. Second thing they told me that I have 4 degrees of unsaturation. One thing that I want you guys to know is every degree of unsaturation can be in 2 forms. It's either a double bond or a ring. So if I give you a molecule that looks something like this, you should tell me that here I have 2 degrees of unsaturation because I have 2 double bonds. If I told you about this, here you should tell me that you have 1 degrees of unsaturation because you have a ring. But what if I tell you this? So a benzene ring. A benzene ring is going to have 1 for the ring, but also have 3 double bonds. So that's going to give you a total of 4 degrees of unsaturation. And they told me in the question that I have 4 degrees of unsaturation. And I want you guys to know something. Whenever you see 4 degrees of unsaturation, 90% of the times it's going to be this structure, which is a benzene ring. About 90% of the times. So they tell me degrees of unsaturation is 4. They give me a big hint, which is telling me that I have a benzene ring. And as we know, benzene rings usually have hydrogens on them, right? So I'm not sure how many hydrogens this one's gonna have, but I know I should have some hydrogens in the aromatic region. And if I look, I do have some in the aromatic region, which is right here. I have 2 of them, which is perfect. Again, the aromatic region on the HNMR is somewhere between 6.5 and 8. Just gonna write it right here, 6.5 and 8. That's where you can find the hydrogens that are on the benzene ring on the HNMR spectrum. So I have the equation, which is C12H18, which is perfect. I know I have a benzene ring, and that's all I know so far. So now I'm going to start using my HNMR data in order to be able to draw the rest of the molecule. So I notice that I have this right here, which has 7 beaks in it. So this one has 7 beaks. If it has 7 beaks, that tells me that it had 6 neighboring hydrogens. And how do I know that? Because I know the way that I got the 7 is the rule, which is n plus 1 rule. So it's like the number of neighboring hydrogen plus 1. That's telling me how many beaks it has. It has 7 beaks, which tells me that this n is equal to 6. So I have 6 neighboring hydrogens in this beak. For this one right here, it's a doublet, so that tells me it has only 1 neighboring hydrogen on the side. Just gonna make that green so it's consistent. Alright, so this trend, I want you guys to also know, whenever you see a septet or 7 beaks that represents 1 hydrogen next to a doublet that represents 6 hydrogen, this is a really common trend that I want you guys to know. So I'm going to draw it right here. If you see septet, which is 1, 2, 3, 4, 5, 6, 7. This one has 7 peaks, but only represents 1 hydrogen. And right next to it, you see this, which is a doublet. So it has 2 peaks, and it represents 6 hydrogens. It is safe to assume that you're looking for a molecule that looks something like this, and I'm going to explain that soon, why that's the reason. So I see 6 hydrogens. First thing I want you guys to think about, how can 6 hydrogens share the same signal? Most likely it's in the form of a CH3 with another CH3, right? So this is my first CH3 and that's my second CH3. Perfect. Those CH3s are both connected on 1 carbon that has a single hydrogen on it, which is this hydrogen right here. So this hydrogen is actually the exact same thing as this hydrogen right here. That is a septet. Why does it have 7 peaks? Because it has 6 neighboring hydrogens. What are those 6 neighboring hydrogens? They are those pink hydrogens right here. Same thing for the 6 pink hydrogens. They form a doublet because they have only 1 neighboring hydrogen, which is this green one. So this is a very common trend. Try to memorize that trend. It's going to be very, very beneficial for you. It's right here. So a septet right next to a doublet usually indicates this. Alright, I'm actually just going to erase this and move this down. Alright. So now I know that this is going to be part of my molecule, for sure. And I know that there's a benzene ring, so most likely this R is my benzene ring. Do you guys remember how I said there's 4 degrees of unsaturation, which most likely indicates that I have a benzene ring? So I'm going to have this and this, and I'm going to have my benzene ring right here. Right, so now I'm going to count my hydrogens because I know I'm supposed to have 12 carbons and 18 hydrogens. Sorry, this was supposed to be 18. Alright, so let's count the carbon first. So 12 carbons, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So far I have 9 carbons. So I'm missing 3 carbons. And the hydrogens, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So now I have 12 hydrogens out of the 18 hydrogens, which most likely tells me that there is this right here, because I'm missing 3 carbons, right? That's my first carbon, that's my second carbon, and that's my third carbon. And if I do this, now we count everything. I'm going to have 3 here, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right here. So those are my 18 hydrogens and my 12 carbons. So that's all I need to know for this. So how can you solve this a little faster? How can you think about this in a much simpler way? So I know I have a degrees of unsaturation of 4, so I immediately say I have this. Then the second thing that I know is they told me this trend right here. So I know I have this in my solution for sure, or in my molecule for sure. Then they told me, do you guys remember how the formula said that I have 18 hydrogens, but they only gave me 9 hydrogens, which most likely tell me there is symmetry in my molecule. There's 100% symmetry, because even though I have 18 hydrogens, only 9 were represented by the HNMR. So what that tells me that there's symmetry, so I know that just if I'm going to put this on top of the benzene ring, it's going to look something like this. And what's the only way that I can maintain symmetry after I did this? The only way in order to maintain symmetry is to draw another one, the exact same thing on the other side. And now everything is symmetrical in the molecule. And that's how you can solve a question like this. So again, just to quick recap, I started with my formula that had 12 carbons and 18 hydrogens. They told me the degrees of unsaturation is 4, so I knew there is a benzene ring for sure. I looked at my equation, I looked at my HNMR, and I said, okay, they gave me some information. They gave me a septet right next to a doublet. Whenever I see a septet right next to a doublet, I'm gonna know that I have this group right here. So now I know I have the group, and I know I have the benzene ring. I put those together, the benzene ring on this group, and I did not reach the number of carbons, I did not reach the number of hydrogens. I'm still missing 3 carbons, and that's when we added these 3 carbons, which is this, this, and this. And when we added these 3 carbons, we were able to maintain the number of the correct number of hydrogens and the correct numbers of carbons. And just to quick recap, let's look at the HNMR. Let's see, does everything make sense? So those 6 hydrogens right here are those 6 hydrogens. 1, 2, 3, 4, 5, 6. So those 6 hydrogens are the exact same thing as those right here. So let's make it the same color. So those are the same thing as these 6 hydrogens. This 1 hydrogen right here is the exact same thing as this 1 hydrogen right here. And it has 7 peaks because it has 6 neighboring hydrogens, which are the 2 CH3s. And then I noticed that I have these 2, which are this hydrogen and this hydrogen. And those 2 hydrogens are right here. Do you guys remember the aromatic region, which is somewhere between 6.5 and 8? So right here, that's in my aromatic region, which confirms that those hydrogens are actually on a benzene ring, and they're those hydrogens right here. Alright, so now that's what I meant by symmetry. Do you guys see the symmetry right now? If I cut this way, you're going to see the exact same thing on the other side. You're going to see these hydrogens. You're going to see this hydrogen. And you're going to see all of those hydrogens. And that's why on the HNMR they only told me there's 9 hydrogens. Even though there's 18 hydrogens, they only said, okay, we're just going to focus on this top and you'll be able to figure out the rest of it because it's symmetrical. And we already told you there's 18 hydrogens from the chemical equation or from the chemical formula, so you should know that there's 18 hydrogens, not only 9. So that's how we got the 12 carbons and the 18 hydrogens. Alright, hope this was helpful, and hope to see you guys in session soon.